right, this is our last part of 1.6. We're going to look at Newton's law of cooling. It's so funny. Every time I see Newton now, I think of Jimmy Neutron. I have a daughter who's now 20, but we watched a lot of Jimmy Neutron when she was younger. Okay, so here's the formula. T of T equals T naught. This is the initial temperature of an object. And this is the temperature of the room. Okay, so let's write that down. This right here is initial temperature of the object. Initial temperature, I'm just going to write temp of object. Okay, and then what's C? The constant temperature of the surrounding area. Constant temperature of surrounding area. Okay, now what else do we need to know? T. T is the time it takes to cool. Time to cool. Okay, so we're going to do a real problem here. Example, cup of coffee is going to be 130 degrees Fahrenheit. Okay, in a room that is 70 degrees Fahrenheit. That sounds realistic. Okay. After 1.5 minutes, 1.5 minutes, the coffee is 125 degrees Fahrenheit. Okay? So, first question, find an equation T of T after T minutes. Okay, so we're going to take this and we're going to find an equation that we can apply so that we know after any time of minutes, we'll know the temperature of the coffee. Okay, so let's start with T of T equals T naught was the initial temperature, that's 130 degrees, minus the constant temperature of the room, which is 70. That's what that is. All right. We're going to multiply that times E, and we have negative R. We don't know what that is, so we're just going to solve for R. And T, they told us, was 1.5 minutes. 1.5 minutes goes into T. All right, and then we have plus our constant plus 70. All right, so they give us some information. They say after 1.5 minutes, the coffee is 125 degrees. So here we put 1.5 minutes. So the temperature is going to be 125 degrees. Okay, 130 minus 70 is going to be 60. E to the negative R, 1.5 plus 70. All right, from here we're just going to do some algebra. First thing we're going to do, right here we want to keep this because we're going to solve for R, so we have to get rid of this plus 70. We're going to minus 70 from both sides, and in doing so, we get 55 equals 60 e to the negative R times 1.5. All right, so now we ask ourselves, what's the next step? What are we trying to solve for? We're trying to solve for R. This 60 is in the way, so let's divide both sides by 60. So I'm going to go ahead and erase this right here and continue the problem up there. Okay, so now we're up here. We want to get this alone, so we divide both sides by 60, so we have to 55 divided by 60 equals e to the negative R 1.5. And what do we do from here? You are absolutely right. We're going to ln both sides. ln 55 over 60. We could have reduced that, but it's okay. We don't need to since we have calculators. Okay, it should be 1.5. All right, using our property, we're going to go ahead and bring this down over. So I'm going to keep this ln of 55 over 60 equals negative r times 1.5 ln of e, which we know equals 1. Okay, now we solve for r, and after doing our work, r is approximately 0.058. Okay, so now we can do what it asked for. Find an equation, T of t after t minutes. So here's our equation. It's going to be kind of like our formula. We can put any minutes in there and find out the temperature of the coffee. All right, so our formula is 60 e to the negative 0.058 t plus 70. That's kind of fun. All right, so now let's do our second question. We had number 1 here. Second question. How long will it take for the coffee to be 112 degrees Fahrenheit? How long will it take for the coffee to be 112 Fahrenheit? Well, that makes sense. 112 is going to go right there. Okay, so we have 112 equals 60 e to the negative 0.058 t plus 70. And the rest is just algebra. Subtract the 70, divide by 60, blah, 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 blah. And the answer is going to be about 6.15 minutes.